Hello, today I'm going to go over energy diagram identification. And it talks about these energy diagrams a little bit here, and what happens when we break bonds or when we make new bonds in a chemical reaction. And this is showing energy that goes into these processes. So what these diagrams are showing is energy along the y-axis. So energy increases going up. And then along the x-axis, this is the progress of reaction going that direction. And it shows what energy is in a molecule to begin with. Now, we want to, in a chemical reaction, we're going to take a molecule, we're going to break it apart. Now, energy is required to go into the bonds holding it together in order to break it apart. So this, all of this energy is added to the molecule in order to break the bonds. Now, once those bonds break, you have two new products. They can then go bond with other molecules. And when they do that and they form new bonds, that's actually going to be releasing energy. Now, in this case, it releases more than just the energy that went in. So here's how much went in, and then it releases the same amount here, right? So this equals that. But it also releases a little bit more. You can see from here to here, this is extra. So this is released. And that's given off as energy from the system. And then it says for our problem here, label each example as either net energy gain or loss. Well, since it's releasing energy, there is a net loss of energy after this reaction, or for this reaction. Now let's look at a different one. This one looks similar, but our ending point is in a different place. So we start with a certain amount of energy in the molecules. We need this much to break those molecules to cause the chemical reaction. And when they form new bonds, it releases this much energy. Well, you can already see that more energy had to go in to break the bonds than was released. That means this much energy from here to here had to be absorbed for this reaction to happen. And this is absorbed from the environment. So during these reactions, they feel cold to the touch because they're pulling in energy. It has to pull in this much energy for that whole chemical reaction to happen. So in this particular case, there's a net gain of energy. So do the same for these two. Figure out whether it's a net gain or loss, and you write that below. That's for these four examples. Now the second page, similar idea, but we're gonna do a little bit more. We're gonna see if the reaction is hot or cold based on whether energy is released or absorbed. And we're gonna write in arrows showing where that energy is released or absorbed. So let's do this first one together. We've seen this before. It takes a certain amount of energy in order to break the bonds. New bonds form and release this much energy. But that's not enough for this whole reaction to happen. So you're gonna draw on your arrows here. And in this particular case, we need extra energy. So this is absorbed. And then we're saying, is this a hot reaction or a cold reaction? Like if you were holding a test tube with this reaction happening in it, would the test tube feel hot or cold? Well, since we're absorbing energy into the bonds, it has to pull it from the environment, which means it feels cold to the touch. That was the same of what we said back here. All right, now, let's see here. This example looks a little different, right? This is how much energy went into breaking the bonds, and this is how much energy was released. So more was released than went into breaking them. Okay, that means we have some extra, and our extra amount is this. So we're drawing in the arrows, and since it was extra, it's going to be released. This released energy you can feel as heat. So in this case, the reaction would feel hot because it's giving off extra energy, and that goes into the environment. Okay, do the same for the rest of these as I did for these two, including the arrows, the absorbed and released, and whether it's hot or cold. All right, hope this helps. Thanks.